Hello, this and my other YouTube videos are extracted from the History of Man series, currently 6 books published in print, ebook, and most importantly, audiobook. I'm a storyteller, and if you like these video stories, you'll love the History of Man series audiobooks. Great for commuting, or just sitting back and relaxing. And unlike a novel you've read where you know the ending, you can listen to these books on tape more than once. There's so much to learn. Available on Amazon and Audible.com, I narrate the audiobooks. And the best part about that is you can listen to these stories without having to look at my stupid face. And with that said, let's get the show on the road. Hello, this is John Bershoff with another episode of History of Man series. Today's topic, the habitable zone and the right stuff. Astrobiology is the study of the habitable zone, the orbital region around a sun, a star that can sustain life. Habitable zones exist even within a galaxy, even within a planet itself. More on that to come. Now, a planet too close to its sun, it's hot. Water evaporates. And life without water is impossible. Not enough things can happen that need to happen for life to happen. Too far away from the sun, it's too cold. Water's frozen, if it's even present. And the same thing. It's cold. Not enough things that can happen, that need to happen for life to happen, will happen. Life without water is impossible anywhere in the universe. Scientists agree. There is no liquid, no fluid even imaginable other than water anywhere in the universe that can sustain life. A planet with water is the beginning of having the right stuff, and that occurs in the habitable zone of that solar system. Like the Tom Wolfe 1979 book, The Right Stuff, and the 1983 movie of the same name, which was about the US Mercury 7 astronauts, the first Americans in space who had the right stuff. Now, the first man in space was Russian Yuri Gagarin, April 1961. He landed by parachute. I guess he ditched his capsule, but he lasted 108 minutes in space and circled Earth once. And he got beyond the Kármán line, beyond Earth's significant gravity where aerodynamics peter out, the Kármán line. Now, the Russians were ahead of the US in space exploration, which is why President John F. Kennedy, in the race for space, committed US dollars to the program. The first American in space of the Mercury 7 was Alan Shepard, May 1961. He landed with his capsule intact by parachute in the ocean. His flight only lasted 15 minutes, 28 seconds, but he made it past the Kármán line. First life in space from Earth was a monkey in space, Albert II, June 1949. He did probably a suborbital flight, probably didn't get beyond the Kármán line. And sadly, he died on impact because his parachute did not open. It failed. But we're talking about the habitable zone. In our solar system, our sun, we have the right sort of star, the right sort of sun, the right stuff. A normal sequence star, our sun, at 4.6 billion years old, halfway through its life. Our sun is due to die in about 7 billion years. A supernova, which is a star explosion. And the only thing alive then will probably be Keith Richards of the Rolling Stones. Interestingly, really large blazing stars out there in the universe consume their fuel so quickly that they die a star death sooner than your garden variety star like our sun. This is from the 6th century BC Chinese philosopher Lao Tzu. The flame that burns twice as bright burns half as long. But back to habitable zone. Earth is nicely situated in the habitable zone of our solar system, 93 million miles from the sun. If it was 5% closer or 15% further from our sun, life on Earth, if it even started, would not have evolved very far. Earth is in the Goldilocks zone of our solar system, but that's not enough. You must have an atmosphere of gases to hold on to your water. Too close to the sun, and all that water evaporates. Too far, and all that water freezes. Consider Venus. It's about 25 million miles closer to the sun at 67 million miles away, with a thick atmosphere of carbon dioxide and sulfuric acid. But it is too hot. If it ever had water early in its existence, billions of years ago, all its water evaporated into the cosmos. Since it is about 800 degrees Fahrenheit day or night on Venus, its water just boiled away. Now consider Mars, 50 million miles further away from the sun than is Earth, at 146 million miles. It has no significant atmosphere to retain water. You need a greenhouse atmosphere to hold on to your water. No water means no life. And also, without much of an atmosphere, Mars at the equator during the day might reach a pleasant 70 degrees, but plummets to minus 225 degrees Fahrenheit at night, standing in the exact same spot. Life would not evolve at minus 225 degrees on Mars, just like it wouldn't at 800 degrees Fahrenheit on Venus. The habitable zone of life in a solar system also means that planet is able to grab the groceries it needs for life when the planet was first forming, such as water, oxygen, carbon dioxide, and in the case of Earth, Earth grabbed 94 elements, all 94 on the periodic table, from hydrogen, atomic number 1, to uranium, atomic number 92, all of which were just floating in the nearby cosmos. Now, not for this discussion, but elements hydrogen, helium, lithium, the first three formed from the Big Bang 13.8 billion years ago. The rest of the elements on the periodic table, from 4 on up to uranium at 92, formed and still form from exploding stars called supernovas, and from those areas in the cosmos that still enjoy the hot particle soup in order to build from hydrogen to uranium. It's basic chemistry. You need temperature, really hot temperatures, to have two hydrogens form a helium, and so on to lithium, and so on down the, or up the periodic table. Now, our planet is the right sort of stuff between the hot core temperature at 4,000 to 9,000 degrees Fahrenheit. At our core, it's almost as hot as the sun, the surface of the sun, and the mantle, 2,000 to 4,000 degrees Fahrenheit, our crust at 400 to 700 degrees Fahrenheit. It keeps our planet warm, plus the sun's retained radiance by our atmosphere, the chemical reactions that needed to take place, inorganic, then organic, for life, that could take place, did take place. Heat drives chemistry. Important, even geological processes such as a moving continental drift, plate tectonics, and volcanoes and earthquakes, plus an atmosphere and weather patterns and the movement of water in oceans, seas, and lakes and rivers, are all important for life to evolve. A barren planet with little or no geologic activity and odd weather, even if it had water, would not form life. Now, water is essential, but it's not enough. Now, there's also a habitable zone on our planet, on Earth. That is, there is a place on Earth where we can exist. We can't live in the oceans. We're not fishes. Us troglodytes can't. I mean, the ocean makes up 2/3 of our planet, so automatically 2/3 of our planet is off limits to us. You know, we're cave-dwelling mouth breathers, and certainly life needs to be at the right spot on our planet. So the waters are odd. Fishes can live in the ocean and other types of sea life, but not very deep. It's odd life that lives deep in the ocean. But for mouth breathers, we're on the surface. Now, we can't live much above 10,000 feet for sustained periods, although La Recanada, Peru, is at 16,700 feet and people live there year round. Leadville, Colorado is 10,152 feet, and for continuous living, that's about as high as you can get for humans. But most humans on our planet live within several thousand feet above sea level, that small area of the habitable zone. We can't live much higher, and we certainly can't live below that level. There's also a habitable zone within a galaxy. Now, our solar system is nicely situated on the remote Orion arm of the Milky Way, far from the galactic center. Now, the Orion arm, where our solar system is not the same thing as the Orion constellation. In case you were wondering, they just use the same name from Greek mythology. At the center of galaxies, including our Milky Way, is or are huge black holes where stars collapsed upon themselves with such compacted matter that the gravity pulls everything in, including light. Them there black holes have lots of gravity. Now, why are black holes black? No light. It's not because at the center of every black hole is an old man with a flashlight looking for the circuit breaker. Black holes are black because even light gets sucked in. Why does light get sucked in? Because light is not just a wave, it is matter we call photons. Light has mass. So, if a solar system is too close to the galactic center and the tug of the black hole gravity is too great, and also as you get closer to the galactic center, there's stars that are closer to you pulling on you, the influences of gravity will not allow life to get hold. Plus, as you get closer to the galactic center, the burden of radiation zipping about is more intense as you work your way inwards. And that radiation would zap the life out of life if it attempted to evolve too close to the galactic center. Now, too far from the galactic center, at the edge of a galaxy, the orbit of your solar system around your galactic center would be too erratic to allow things to happen. So, Earth and our star is within the sweet spot of our galaxy on the Orion arm, the Milky Way. Earth is within the sweet spot of our solar system, right there, to have water and have all the grocery items it needed. And humans live within the sweet spot on our planet, within a few thousand feet or so, sea level and above. Those are all the right sort of stuff and the sweet spot. Why did life happen on Earth, including advanced life, if we are willing to accept us cave-dwelling, mouth-breathing, troglodyte Homo sapiens are advanced? Life happened on Earth because it could. I hope you enjoyed this episode of History of Man series. I have 6 books out. This is the first History of Man series. There are 5 more. It's a style of writing called jumping off, where I take a base subject, which is, in my case, medicine and science, and jump off into other stories of astronomy, history, and geology, and art, and music. I always return to the subject and keep on moving. I promise you, with the turn of every page, you'll learn something. I certainly did. And I hope you enjoyed this episode. You be well and have a good day. Thank you.